So for students that are gone today, this is Thursday, April 18th. We are now doing the evaluating, analyzing complex circuit business. So we're at this point in your note packets. And so now what we have here is a arrangement of two bulbs in parallel that's in series with C. We have four questions that I'd like to consider here. And in each case, I'd like you to sort of consider this, talk it over with the person that you're sitting next to. When switch S is closed, that S being closed, how would the brightness of bulbs A and B compare to that of C? Think about that for a second. Talk it over with the person that you're sitting next to. How will those brightnesses compare? Take a moment. Go. Okay, kids are talking. If you're watching this video at home, you should be thinking about the same thing. All right. Agree or disagree? A and B are going to be of equal brightness to each other. Agreed. They're in parallel. They have the same voltage drop across each other. They're the same resistance, so they're going to have the same current, all that stuff, same brightness. How will C compare to those two brightnesses? Brighter, less bright, or the same? Close your eyes. Close your eyes. C is going to be brighter. Raise your hand. Okay, let the record know it's about half fast. All right. C is going to be the same brightness. Raise your hand. Record, no one raised. C is going to be dimmer. Raise your hand. A few people saying that. All right. For those that said it's going to be brighter, how do you know? And it is going to be brighter. How do you know? Nice and loud. Theo, go. Okay, listen close.
Because when it's in series, it's split between all the voltage split between the first resistor and the second resistor.
When C is in series with A and B, the voltage is going to be split between them. Okay, keep going.
Yeah, but because the voltage on the second one of the series being A, it's going to split. Yeah.
I'm going to take this be A parallel B. I believe this is what you're saying. And this is C. Is that sort of what you're saying?
Yeah.
Resistance of A and B is smaller than that of C. So delta V here would be bigger than delta V there because the delta V is in proportion to the resistance. That's a way to say that. It's a way to think of it. That explains if power is equal to I times delta V. They have the same current flowing through here. They have the same current. That one's got the bigger voltage drop, so it's got the bigger power. It's going to be brighter than A and B combined. That's what you're saying? Works. Is there a way that we could look at this with current instead of looking at it in terms of voltage? Could I look at this and say, well, the current that flows through here is really big, and then the current flowing through these is going to be smaller because it's having to split up? Could I look at it that way? Yeah. Either way we do it. C is going to be brighter than A and B. Now, next question. What happens if I open switch S? So S I'm going to open. The circuit's going to change. What happens? Turn and tell that person that you're sitting next to. What observations would you make? Go. Yeah, if switch S is open, then A is no longer part of the circuit. So A, but what else would you observe? There's other things that you would observe. Thank you, Malcolm. Nice and loud.
C and B will be the same brightness.
Then C and B would be two identical light bulbs in series. They'd be just as bright as each other. Agree or disagree? C was really bright. When I open up switch S, C is going to dim a little bit. Agree or disagree? C is really bright, right? We said that. And then I open up switch S. Will C dim, or will it stay the same brightness as it was before? It'll dim. And how you know it's going to dim as well?
Because the resistance of A and B goes down.
Yeah, the resistance actually goes up. When I open up A, the resistance of A and B increases because I now only have B, right? So the overall current goes down, and C will actually be dimmer than it was before, but it'll be the same brightness as B. Okay. What happens if bulb C burns out? Just open-ended comment. C burns out. What happens to that circuit? Everything shuts down. Because everything flows through C. So if C opens, everything shuts down. Last question. What happens to bulb C's brightness if switch S stays closed but bulb A burns out? Would you guys agree that letter D is exactly the same question as letter D and B are essentially the same thing? Whether or not I open the switch or bulb A burns out, effectively that portion of that circuit is dead. Good? Okay, now, kids that are not here today need to watch that video. I'm going to show you guys now how to analyze exactly that circuit. When you take a look at that circuit, do you guys agree that that's exactly the same thing we just looked at?
Yes.
It has a battery, it has a single resistor, everything flows through that. It splits up and it flows through those and it combines back through them. I'm going to analyze that circuit. Now, we need more space than what I've given them other problems. So I'm going to do these along with you. Hopefully this will make sense as we go through it. I'm going to take this arrangement of resistors, and I'm going to think of those as a single resistance that's equivalent to that resistor. So what I'm going to do is I'm going to draw a little circuit over here that shows me replacing R2 and 3 with an equivalent resistance. So I'm going to say that's R1, and I'm going to replace, I'm going to call this R2 in parallel with R3. Now I know those values, they're 30 and 60. I'm going to show you a little trick on how to calculate that value simply. Instead of having to do 1 over Req is equal to 1 over R1 plus 1 over R2 plus 1 over, when you only have 2 resistors and they are in parallel, the equivalent resistance, R equivalent, is equal to the product over the sums. And you can prove that mathematically. You're finding the least common denominator, the LCD is R2, R3. If I make each of those have the same LCD, it becomes a product over the sums. It makes it quicker to do than having to go through and do 1 over R1 plus 1 over R2 and so forth. So 30 times 60, Req, would be equal to 30 multiplied by 60 divided by 90. And that will give me that Req more quickly. It'll be 20 ohms. Now that's a little shortcut for you to be able to do 2 resistors in parallel. Product over sums. Now if I wanted to, I could go through and do one more circuit that simplifies this into a single battery and 1 resistor. This is as simple of a circuit as we can get. Would you agree the equivalent resistance, if this is 10, would you agree the equivalent resistance of this entire thing is 30 ohms? You guys agree?
Yes.
If this is a 15-volt battery and that is a 30 ohm resistance, the current flowing through that source, I, is equal to half an amp. It'd be delta V over R. That'd be 15 over 30. That'd be 0.5 amperes. The current flowing from the battery is 0.5 amps. I can put that right here. This is 0.5. That's I1. It's the same current that I have right there, 0.5 amperes. The current flowing through this is 0.5. The current flowing through this is 0.5. So what I'm doing now, once I go through and I do this, I'm going to start working backwards now. I'm going to go this way to determine what these values are across everything until I finally get back to my original circuit. Could you guys tell me what is the voltage drop across R1? How much does that voltage drop across R1? Half an amp, it's 10 ohms. What's delta V? Delta V1 is 5 volts. I'm just multiplying those two together. What's the voltage drop across these two? Has to be 10. If this is 15, this delta V across this is 10 volts. Correct? Let's take it one more back over here. What's the voltage drop across those two resistors? 10 volts, just like I did here, right? So delta V here is 10 volts. If this is at 15 and this is at 0, this would be at 10, this would be at 0. You guys see it? Our last thing to do is I want to determine the current through R2. I2 would be equal to delta V across R2. That's 10 volts divided by 30 ohms. That would be 0.33 amperes. That's the current through I2. If I have half an amp coming in and 0.33 goes that way, how much must be I3 be? Like 0.167 or so, right? If I wanted to find I3, it'd be delta V over R3, which would be 10 divided by 60, which is 0.167 amps. I can go through and solve everything through that, having to create a more simple circuit from the things that I've given. Okay? That's that process. Now, I'm going to stop the lecture there. I'm not giving you any homework for tonight. We're going to study this more in detail tomorrow. If you're gone tomorrow, we're going to go in more depth on this. Have a fantastic day, folks. If you're gone tomorrow, enjoy U of M. I believe it's a really good school.